Okay, here we go with lesson 108 in Algebra 1, Square Roots Revisited, and Radical Equations. Okay, so a key thing to solving the radical equations we're going to be dealing with is remembering how to undo a square root. Okay, let's do a different one than that. Let's say that you have the square root of 21. And I want to undo that. If I want to undo it, all I have to do is square and it becomes just 21. What happens is the square removes this sign right here. Okay? So if you want to remove the radical sign, you square that side. Okay? And that'll take away the radical sign. That becomes very, very handy, because in this section we're going to do some equations such as example 108.1 that gives me that plus 3 equals 0. Alright, so when you're given an equation and it has a radical sign, the first thing you're going to want to do is get rid of everything on the same side of the equal sign as the radical. It's called isolating the radical. You're getting it all alone. So the first thing we're going to do is we're going to subtract 3 from both sides. So that we have the square root of x minus 2 equals 0 minus 3 is negative 3. So that all goes away. Now once we have the radical isolated, we put a parenthesis around the radical, parenthesis around that, because you can't do one thing on one side of the equal sign without doing it to the other. And we square it. When you square it, you don't even have to think. You just write everything in there, the radicand. You write everything inside the square root sign without a radical sign, without an exponent on it, and then you say it's equal to whatever negative 3 times negative 3 is. And in this case, it's 9. Okay? Now we just solve for x. Add 2 to both sides, and we get x equals 11, and we're done. Okay? Not too terribly difficult. Let's try another one. Let's look at 108.2. Exact same format, nothing different. Square root of x minus 2 minus 6 equals 0. Okay, isolate the radical. Get that negative 6 on the other side, so you add it to both sides. Then you square both sides. And you get x minus 2 with no radical sign or exponent. Add 2, and you get x equals 38. Okay? Pretty quick and painless there. Okay, so one of the things that I want to bring to your attention as we're kind of going through here is the idea of checking your answer. Meaning, once you get an answer, put it back into the original equation, which in this case is that, to make sure it works. Because when you square a radical, you can sometimes get an answer that may be done correctly, but the answer doesn't work. Okay? So even though you get a number and you did the math right, because you're taking the square root or you're squaring a radical, things can get kind of goofy. So let's just assume that we don't really know everything is right until we do some checking. Okay, so we're going to isolate the radical again. Okay, once we do that, we're going to square both sides. And we get x squared plus 9, again, everything that was under there. And we get that. Alright, now what we're going to do is we are going to well, let's look at it a couple ways. We could write it as x squared equals 25 minus 9 is 16. And you get, and then see, now we want to get rid of the square, right? So when you want to get rid of the square, you take the square root of it. So see how you can go either way? Here, to get rid of the radical, you put a square up here. You put a 2 up here, and it goes away. If you want to get rid of the squared, you put a radical here, and the square goes away. And you have to do that to both sides. Okay, when you take the square root of both sides, you get a plus or minus. So you get x equals a plus or minus 4. So x can equal either 4 or negative 4. And then you put both of those numbers in here to see what happens. So 4 squared plus 9 minus 5. Does that equal 0? Well, 16 plus 9 is 25. The square root of 25 is 5. 5 minus 5 is 0. That works. Let's try negative 4. Negative 4. Okay, negative 4 times negative 4 is 16. 16 plus 9 is 25. Square root of 25 is 5. 5 minus 5 is 0. So that works as well. So those both work. Okay, let's go on to the next one, which I'll tell you right now will not work. So let's do the math and just watch and see what's going on here. And you'll notice that all the math is done the exact same way. Everything's being done correctly. Alright, minus 3 plus x equals 0. So let's move everything over except the radical. And that'll be a plus 3 minus x. Because when we move these over here, they change signs. Alright, so now, remember what I said? We square both sides. And when we square both sides over here, we don't just square the 3 and then the x. We square the entire side, just like we did over here. We squared the whole thing. Alright, so now we have x minus 1, and then 3 minus x times 3 minus x. That's what happens when we square, right? So let's do the FOIL. First one gives me 9. Outside gives me negative 3x. Inside gives me negative 3x. Last gives me a positive x squared. X times x is x squared. Alright, so let's start combining. X minus 1 equals 9 minus 6x plus x squared. Let's move these over. So that's going to be a plus 1 and a minus x. So that gives me a 10 minus 7x plus x squared. Alright, let's rearrange these and write it as x squared minus 7x plus 10 equals 0. So I took this, moved them to the other side, and moved the 0 over here, and just switched the numbers around so that my x squared was first. Okay? Alright, now I break this into two binomials. X, 5, and 2. And the bigger number has to be that sign, and that's going to be a negative also, so that when I take negative 5 plus negative 2, I get negative 7. Negative 5 times negative 2 is positive 10. Okay, life is looking pretty good here. Alright, so my x then is what makes this 0, 5. My other x is what makes this 0, a 2. So let's take our 5 and our 2 and put them clear back up here in our original problem. Okay, so let's move this over. Let's move this down. Okay, so here's our original problem, right? And let's put a 5 in. Square root of 5 minus 1 minus 3 plus x. What did we say x was? 5. So, square root of 4 minus 3 plus 5 equals 0. What is the square root of 4? 2 minus 3 plus 5. What's 2 minus 3? Negative 1 plus 5 equals 0. So 4 equals 0. It does not. Okay? So because 4 does not equal 0, 5 does not work. Alright? So let's go up and do the exact same thing, and let's use our 2. So again, we're using this equation down here. So I have the square root of x minus 1, 2 minus 1 minus 3 plus x, again 2, and that gives me square root of 1 is 1. 1 minus 3 is negative 2. 0 equals 0. That is a true statement. So therefore, our 2 works. Our 5 did not work, but our 2 did work. Okay, so just something to remember there. Okay, 108.5. Now this one gets to be just a little bit tricky, but it's not too bad. Whoops. Getting ahead of myself. Alright, notice what we have. We have a radical on either side of the equal sign. They're both isolated. They're both by themselves. Rule still works the exact same way. You get one of the radicals. It doesn't matter if there's 1, 2, 3, or 4. You get one of the radicals by itself on one side of the equal sign. Well, at this point we do. Both of these radicals are on one side of the equal sign alone. Once you do that, which in this case it's already done, you square both sides. And what happens? The radical sign comes off of that, and the radical sign comes off of that. Now it's really easy to solve. Subtract x from both sides. Add 5. Oops, I had 3. I don't know why it's adding 5. Add 3. Maybe that's why, it's because I get 5. Okay, so I get x equals 5. Now what I have to do is take my answer of x minus 5, put it back in the original. Oops, that's a little bit long. Got a little carried away. 2 times, what did they say x was? 5. Square root of x is 5. Alright, what do I get here? 10 minus 3 is 7. 5 plus 2 is 7. Those are equal to each other. Even though they're still under radical signs, they're equal to each other, right? Square root of 7 equals square root of 7. That means x equals 5 works, and that ends up being a solution set. Okay, so that's it for lesson 108.